This is lesson 2.7 on percent of change that we're going over today. So the percent of change is whenever an increase or a decrease in an amount is expressed as a percent, right? So if something used to cost $10 and now it costs $12.50, what was the percent of increase, right? It went up in price, but by how much percent? So that's what we're trying to figure out here. If the new number is greater than the original, if it went up from original to the new, it's a percent of increase. If it went down from the original to the new, if the new number is less than the original, it's a percent of decrease. All right, so we've got an example here. And basically, when I'm teaching this in class, I have students write on their papers, it's the new amount minus the original over the original, right? That fraction, once you simplify, gives us the percent. If the top number is positive, it's a percent of increase. If the top number here ends up being negative, it is a percent of decrease. So here for example 1, the new amount is 60. The original amount was 48. So we went up, obviously. 48 to 60, we went up. This is going to be a percent of increase. So we're going to, on top, write new minus original, 60 minus 48. Over 48, right? So on top, 60 minus 48 is 12. So we're going to have 12 over 48, which is what they set up here. 12 over 48 equals the percent of change over 100, right? So that's the proportion that we're trying to solve. So then we cross multiply, just like we've done in proportions. So 48 times R equals 12 times 100. 12 times 100 is 1,200. That should equal 48R. And then once we divide both sides of our equal sign by 48, we should get R equals 25, right? So if we put that back up here, we would get 25 over 100. And remember, percent is out of 100. So this is 25%. Since it's a positive number, that means it went up 25%. If we had got negative 25 here, that means it went down 25%. So it's a percent of increase at 25%, right? So you always have to tell whether it was an increase or a decrease, because if you're making 25% more money, that's a lot different than if you're making 25% less money, right? So we need to know which way it's going and then by how much. And again, I wrote here, if it goes up, if it's the answer is positive, if the new amount is bigger than the old amount, then it's a percent of increase. If the new amount is less than the old amount and this top number here is negative, then it's a percent of decrease. So we've got a few examples to do down here. Before we do that, we'll look at this other example here. I haven't looked at that one yet. Okay, for the second example, it says find the percent of decrease. So this one will go down, and we notice that we start off with 30%, and the newest amount is 22. So something started at 30 and went down to 22. So it decreased, but by how much, right? So we're going to do new minus original over the original. And whatever that is equal to our percent, right? Is equal to the percent over 100. So 22 minus 30, here they did that as 8. So then this becomes 8 over 30. Equals our percent we're looking for over 100. This is where they are. Then we cross multiply. Oh, they did it opposite. No, sorry. I always do new minus original. They did original minus new. If we do new minus original, 22 minus 30, we get negative 8. Okay, so when we write it down, we get negative 8 over 30 equals R over 100. And we still cross multiply. The only difference is this is a negative 8. So for this answer here, we're going to have negative 800 equals 30R. Then we divide both sides of our equal sign by 30 to get R alone. And we end up with negative 26 2/3, right? So our percent is a decrease, our percent of decrease, and it's 26 2/3%. Or if you did that as a decimal, it'd be 26.67%. About 27% if they wanted you to round to the nearest whole number. Okay, so if your answer is negative, and you always use new minus original over original, I think they did something else funny here. Don't change it. Don't do it different based off of increase or decrease. Always do new minus original over the original. And if your answer at the end is positive, it's a percent of increase. If your answer at the end is negative, it's a percent of decrease. So let's do a few of these examples. These will look like some that you might see on your assignment this week. So first off here we have number 1. I'm just going to do the odd problems. Here, I'll zoom in. All right, number 1, we have original, we have 50, new, we have 80, right? So we're gonna do new minus original over the original, which is equal to 30 over 80. Now, you have options here. You can either set this equal to x over 100 and cross multiply and solve for x, and x will be your percentage, or you can just take this fraction right here and divide it, change it to a decimal. And then we have 30 divided by 80, so we'll do 30 divided by 80. And we get 0.375, which is our percentage just written as a decimal. So all we have to do to write it as a percent is move the decimal point back 1, 2. We took 37.5, divided it by 100, and that's what gave us 0.375. So if we multiplied it back by 100, our decimal point would move and we'd have 37.5. So just for the sake of time, and because I think you guys are all big fans of saving time and less is more and you don't want to do extra work, right? I'm going to just do all of them that way. I'm going to take this fraction, divide the top by the bottom, and then just move the decimal place over 2. That's all I'm going to do. All right, so let's do number 3 next. Go way over here to number 3. Move my paper, got all these obstacles. All right, so I want new minus original. So I'm going to have 20 minus 45 over 45. 20 minus 45 is negative 25 over 45. So I have a negative. That tells me it's a percent of decrease. And then if I did negative 25, I'll do my negative there, divided by, what did I say, 40? 45? No, sorry. Yeah, negative 25 divided by 45. Divided by 45. I get negative 0.555555. Negative 0.55555. And so if I move my decimal place back 2 spaces, that equals 55.6% if I round it. Right? All I did was take the decimal and move, and it keeps having these 5s go back. That's how I got this 0.6 at the end, 0.5555555. Usually it tells you to round to the nearest whole number. Did it say that? Yes, round to the nearest whole number in the directions. So we would actually round this to 56%. 56% of decrease. You have to say it's decreasing. It didn't go up 56%. It went down 56% to get from 45 to 20. All right, let's keep doing that. If that's confusing, let's do a few more. All right, here's number 5. That was 1, 3, and here's 5. So we're going to do new minus original over the original. So 150 minus 140 is 10 over 140. Then I'm just going to change that to a decimal. 10 divided by 140 equals 0.071. 0.071. And if I change that to a percentage, I move the decimal place 2 back, so I get 7.1%. And it tells me to round to the nearest whole percent. So 0.71 is closest to 7%, and it went up, it's positive, so it's 7% increase. Okay, and then I'm gonna do number 7. Here's 7. So I have new minus original, 180 minus 120 over 120. And that's 180 minus 120 is 60 over 120. And if in our calculators we divide 60 by 120, we get 0.5. And if we move our decimal place over 1, 2, we got to put a 0 here, move it over 1, 2, that's 50%. 50%, and it was a positive 0.5, so it's a 50% increase. Okay, let's scoot over to number 9. Here we are, so there's stuff written around it. The original was 27.5, the new is 25, so it looks like it went down. New minus original over original. New minus original is negative 2.5 over 27.5. If we divide that in our calculator, what did I say, 2.5? Yeah, 2.5 and make that negative, oops, negative 2.5 divided by 27.5 equals, and then I want to move my decimal place over 2. And another way to do that is just multiply by 100 times 100 equals negative 9 point blah, 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 right? Which would just round this to negative 9. So my answer is not negative 9. My answer is 9%. The negative tells me that it went down. It is a decrease. 9% decrease. Sorry, I squished that. So please don't put your answer that it's negative 9%. You're going to say it's a 9% decrease. If it's positive, that was an increase. If it's negative, that was a decrease. Last one. All right, our original is 12.5. Our new is 10. So new minus original over the original. That's negative 2.5 over 12.5. So if we divide that, 2.5, and to change it to negative, after I type the number, I type this little guy and it adds a negative sign, divided by 12.5 equals that times 100. That moves my decimal place over. So it's negative 20%. Or in other words, I'll put negative 20, so that's a 20% decrease. I'm going to know if you watch the video to the end or not by how you put your answer. If you put negative 20, I'll know you didn't watch it till the end. You got to write decrease if this is negative. Okay, let's go on. We're going to set up our little proportion the same way for the back side of the sheet, but in this case, let me zoom out, they're actually going to give us sometimes the percent of increase or decrease, and we have to find something else, like maybe we'll have to find the new amount or the original amount. We'll have to find a different piece. So our, let me get my colored pencils here. Our whole formula is new minus original. I'll write it over here. New minus original. Oh, come on. Minus original over original. And that's equal to whatever the percent of change is over 100, right? That's what we're looking for here. So new minus original over the original equals whatever the percent of change is over 100. If it went down, if it said it was a decrease of 5%, you'd put negative 5 here. If it said it was an increase of 5%, you'd put positive 5 here. Don't forget that part. Okay, so reading this top portion, it says, I know you can't see it all, but the study guide is included in this folder, so you can always print it out and look at it. Discounted prices and prices including tax or applications of percent of change. Discount is the amount by which a regular price of an item is reduced. Thus, the discounted price is an example of a percent of decrease. Sales tax is an amount that's added to the cost of an item, so the price including tax is an example of the percent of increase. Right? We get that. You go buy something somewhere and they say, oh, it's on sale, 20% off. Well, that's a 20% decrease. So you got to figure out, okay, well, what is 20%? Then you got to subtract it from the amount, right? You have to figure all that out. If they say there's a 7% sales tax, then you got to increase the amount by 7%. So there's percent of change, and we can use that all the time. All right, example. A coat is on sale 25% off the original price. If the original price of the coat is $75, what is the discounted price? Okay, so if I kind of ignore what they're doing over here and I just figure it out right here. New minus original. Well, the new amount would be the amount after the discount. That's what I'm trying to find. I don't know what the new amount after the discount is, but I know the original amount was $75. That's what it told me. So I'm going to do new minus original over the original. And it says it was discounted at 25%, or it was 25% off. So the cost didn't go up 25, it went down 25%. 25 out of 100, that's per cent. There's 100 cents in a dollar, so 1 penny is 1 cent per cent, 25%. And it's negative since it decreased. Okay, so now I can actually cross multiply and solve. So I'm going to cross multiply this way, and I'll get negative 25 times 75. And I set that equal to cross multiplying the other way. So I have x minus 75 times 100. Right? And now we have distributive property and we can simplify. So here, negative 25 times 75 is negative 1875 equals, and then this is 100x minus 7500 after I distribute. Remember, multiply each term inside parentheses by the number outside. And now I have to solve for x, so I'm going to add 7500 to both sides. So 7500 added to 1875, 5625, and then I have to divide both sides by 100. So that's $56.25. Because remember, that number was the new amount. That's what we were looking for up here. So after a $75 coat is discounted 25%, you're going to pay $56.25 for it. Now then, after you do all that, it might say after the discount, they bought the coat and there was a 7% sales tax. So then this would be your original amount, and you'd have to add 7%, right? You'd have to put positive 7% here because it'd be making your amount go up. So you do x minus, this would be your new original amount over that same thing, and you'd be searching for a new that included the sales tax, but we'll have problems like that we'll get to. Okay, so let's do a few examples. Let me highlight the ones I'm doing so I don't get off track. I'm gonna do that one, 5. Oh, we got 2 word problems down here at the bottom. Okay, I'm gonna do it in purple because why not? All right, so for number 1, I'll zoom in a little bit here. And I'm gonna have to squish my work. It never gives you enough room to do this. Find the total price of each item. All right, so sales tax is 4%. When you see the percentage, that goes on the right-hand side, right? So we're doing new minus original. A shirt is originally $24. Then it has a sales tax of 4%, right? So our new amount is gonna be 24 plus whatever the sales tax is. So I don't know what the new amount is. So I'm gonna say new minus original over original equals, and sales tax makes our amount go up, so that's a positive 4. Right? So once I write my proportion, then I can cross multiply, and I'm going to write that answer here. 4 times 24 is minus 1 to the 96. And then 100 times x is 100x minus 2400. So that's what our equation is going to look like. To solve for x, I'm going to add 2400 on both sides. Yeah, because right now it's minus 2400. So over here, I'm going to end up with 2496 equals 100x. And then once I divide both sides here by 100, I'm going to have x equals 2496. So this is my new amount after a 4% sales tax. Cost $24 for the shirt, plus sales tax of 4%. I'm paying a total of $24.96. We're going to set them up the exact same way every single time. Now we're going to do number 3. Celebrity calendar cost $10.95 originally, sales tax of 7.5%. So new, we don't know what the amount yet is before the sales tax. So new minus original over the original equals, and then the amount of increase is 7.5%, and it's going up, so we're going to leave it positive, over 100. Then we're going to cross multiply and write that out here. And I'm squishing because if I wrote out every single step, that's a lot of steps. Hopefully you guys are following along with what I'm saying. Okay, so I'm going to do 1095 times 7.5. 10.95 times 7.5. That gives me 82.125. 82.125 equals, and then x minus 1095 times 100 gives me 100x minus, and 100 times 1095 is just 1095, no decimal. Multiplying by 100 moves the decimal back 2 spaces. How many zeros there are here, that's how many spaces our decimal moves back. Okay, so now we've got this. Now I've got to add 1095 or 1095 to both sides of my equal sign. Those go away. So I have this. I'm adding 1095. So I get 1177.125. 1177.125 equals 100x. And I've got to divide by 100. Now I'm not multiplying by 100, I'm dividing by 100. So my decimal place is going to move 2 spaces to the left. So it's going to be 1177 and some decimal that's not going to round it up any more than that. So x equals 1177 with sales tax. Started off as 1095. We added 7.5% sales tax. Now the total is 11.77. Hopefully you guys can follow that okay with this, squeezing it into this little space. All right, number 5. It says find the discounted price of each item here in these directions. Discounted, so it's going to be going down. 2 concert tickets cost $28. That's the original amount. The student discount, if you buy them and you're a student and you show your ID, you get a discount of 28%. So what's the cost of the new, what's the new cost for the tickets after the discount? So we have new minus original over original equals, and it's going down 28%. It's a discount. It's going down 28%. It didn't go up 28, it went down 28, so we have to put negative 28. Then we're going to cross multiply. It's funny that it's $28 and it went down 28%. All right, so 28 times negative 28 gives us negative 784 equals, and then 100 times x is 100x minus 28 times 100 is 2800. All right, so here's where we're at. Then I've got to add 2800 on both sides of my equal sign. So negative 784 plus 2800 equals 2016. So 2016 equals 100x. And then I have to divide both sides of my equal sign by 100. So the amount here, the new amount after the discount, is going to be $20.16. That's our new amount. It was 28, and then we got 28% off. That's over a quarter off, right? 25% is a quarter of the price. So we got over a quarter of the price off. So now we're just paying $20.16. All right, 2 word problems. I'm going to scoot out just a little bit so we can see them better. I know you can't see all of it still. All right, videos. The original selling price of a new sports video was $65. This was the original amount. Due to the demand, the price was increased to $87.75. This is the new amount. New, this is original. What was the percent of increase over the original price? So we have the new, we have the original. What's the percent of increase? So we use new minus original over the original. So new is 87.75 minus the original, 65, over the original, right? And when we're looking for the percent, this is where we can do our little shortcut. So 87.75 minus 65 equals 22.75 over 65. And then I can go ahead and divide 22.75 by 65. And I get 0.35. 0.35. 0.35. But remember, when I do it that way, if I just divide the top by the bottom, it gives me the decimal version of my percentage. So to change this to a percentage, I have to multiply it by 100 or just move the decimal 2 spaces to the right. So I get 35%. The price went up 35%. It was a 35% increase. Makes sense? We knew it went up. If it started at 65 and it ended at 87.75, we had to figure out how much did it go up. It went up 35%. Okay, last problem for the notes. Thank goodness, right? Baseball. Baseball tickets cost $15 for general admission or $20 for box seats. The sales tax on each ticket is 8%. What's the final cost of each type of ticket? So all we're doing is adding sales tax to both tickets, right? So we can do the percent of change when we're adding 8%, or back in middle school or elementary school when you learned about adding sales tax, right? The little shortcut to this, if all we're doing is adding tax, we're going to multiply the original amount times the decimal version of the tax, so 0.08, because it's 8%. 8 divided by 100 is 0.08. And if we just multiplied this, it wouldn't give us the entire cost with sales tax added. It would just give us whatever the sales tax is. So let's say the sales tax was like $2. That's too much, but let's say it was $2, right? This would just tell us $2. Well, we don't want to know just what the sales tax was. We want to know what the whole amount is added in, right? The ticket and the sales tax. So to do that all in one step, put a 1 in front here. Right? Because now when I multiply 8 times this stuff, bring it down, all this, on my last step, I'm going to multiply the 15 by 1, and it'll get added in down here if I did it the long way, right? So by putting a 1 in front of our percent of change, it adds in the original amount. Just trust me on that. So whenever you want to do a shortcut for sales tax, instead of doing new minus original over original, all that stuff, just multiply your original amount times the sales tax in decimal form with a 1 in front. So here, I'm going to do this in my calculator. 15 times 1.08 equals 16.2. So $16.20. And that's for the general admission. Gen admin. Okay, and then the other box seats were 2 for $20, right? $20, oh, sorry, not 2 for 20, just $20 for a box seat. So we're going to take that $20. Now it's got an 8% sales tax too, so we multiply it by the 0.08. And I don't want to know just what sales tax is. I also want to add it on to the $20 ticket. So I'm going to put a 1 in front here. And if I multiply 20 times 1.08, I get 21.6, which is $21.60. And that's for box seats. All right, so if I showed you on my calculator if I just wanted to know just what the sales tax was for a $20 ticket, I don't want to know what the whole thing is, just the $20 sales tax. I feel like you can see a reflection of like everything up in here. That's okay. Hopefully you can see my calculator. All right, $20 sales ticket times just the increase in sales tax. Sales tax would be 1.6 or $1.60. So if I multiplied the $20 ticket times 0.08, which is the amount of sales tax would be $1.60. But I want to add that on to the price of the ticket and have it all together. So I'm going to multiply the $20 ticket times 1.08, and that adds the $1.60 on to the $20 ticket. See? So the shortcut is take your ticket whenever, for tax only. Tax only. Only when it's a percent of increase. You're going to multiply original amount, I'll say original number, by 1 point, and then the decimal version, decimal percent tax. So if it's 30% tax, you do 0.30, right? And if you're going to multiply, if you want to know the final cost with the sales tax added in, multiply the original cost by 1 point, whatever the sales tax is. All right, if you have questions on that, let me know.